Tell me what is mean by a force. In your lower grade, you have learned about force, no? What is the definition for a force? Sorry?
Push or pull?
Ah, yes. Our primary definition is force is a push or a pull, no? Push or a pull. Push or a pull. Okay. Actually, we have a bit deeper definition in our syllabus, but for now, let's use this one. Push or a pull. Okay. Then tell me, what are the things that can happen when a force is applied on an object? What are the things that can happen? Then, oh, otherwise, tell me how you can understand. Sorry,
It can move.
I can move. Okay, okay. What else? This is our basic knowledge now. From grade 6 onward, we have learned about this one. When force is applied on an object can move. What else? Think like this. The object is moving. Okay, the object is moving, and we apply a force on that object. So, what will be our observation when we applied force on a moving object? What are the things we can see? It can increase its speed. It can increase its speed. Do you know the meaning of acceleration? Acceleration. We say we accelerate the vehicle. Acceleration. Do you know the meaning of that one? Oh, there is something called accelerator. Sorry?
Increasing speed.
Increasing the speed. Okay, that's called as acceleration. What happened when we apply brake on the vehicle? On a vehicle,
It stops.
it stops. Applying brake also a kind of applying a force. Okay, applying a force. So what happened? It reduces speed or it deaccelerate, deaccelerate, deaccelerate. It reduce speed or deaccelerate. Okay, then think about a cricket match. A ball is moving towards a batsman. When batsman hit on the ball, what happened?
The ball moves.
The ball moves to same direction or different direction. Usually the ball moves most of the time to different direction. That means when force is applied on an object, the moving direction also can be changed. Moving direction also can be changed. Understood? Yes or no?
Yes, I understood.
Moving direction also can be changed. Okay, then Think like this. You have a rubber ball. Okay, you have a rubber ball. What you do is you try to pressure it. What happened to that? Oh, think you have a sponge. You pressure it. So what happened to the shape of it? What happened to the shape?
It changes.
Yeah, it changes. So deformations can happen. So it change it original shape. No, those are the main things that can be happen when apply a force. Clear? Then tell
Yes, sir.
me, what is the unit of force? What is the SI unit actually? What is the SI unit of force?
Newtons.
Yes, not Newtons, okay? It's Newton. Newton. Don't use 10 Newtons. Yes, like just like trees, bananas, birds, like. Don't use S, okay? Just like Newton. 10 Newton. This is the SI unit. This is the SI unit. Have you understood up to now? This is the very basic thing.
Yes, sir. Understood.
Okay, then shall we write?
Okay, sir.
Okay, right. Force can be, force can be, force can be, force can be, force can be simply defined as, force can be simply defined as, force can be simply defined as a push or a pull, a push or a pull can be simply defined as a push or a pull. Finish writing?
Yes, sir. Done.
Okay. Write the next point. The SI unit of force is Newton. The SI unit of force is Newton. The SI unit of force is Newton. Okay. Finish writing. Can you hear me? Are you still writing?
No, sir. Finish writing.
Okay. Then Write the next topic. Write the next topic. Effect of effect of applying a force on an object. Effects of applying a force on an object. Effect of applying a force on an object. Okay, then let's draw a table. This side effect, this side example. Effect and example. I will give you the effect. Okay, then you have to write an example for each one. Okay, you have to write the example for each one. It is okay to make mistake. Okay, it's okay. Can you draw a table like this? Just have two column.
Okay, sir. Done, sir.
Okay. In this side write effect, other side write example.
Done, sir.
Okay. Then write the first effect. Start motion. Start motion. Start motion. First one. Then the second one. Stop motion. Stop motion. Stop motion. Then third one. Change speed. Change speed. Change speed. Change speed. Next one. Change direction. Change direction. Change direction. Last one. Change shape. Change shape. Change shape. Okay. Write example for each one. Quickly, okay?
Done, sir.
Okay. What is the example for first one? That
When
is
pushing a ball, object,
when pushing.
a ball or object,
Ah, okay. Second one, stop motion.
when applying brake for a vehicle,
Yes. Change speed, no? Third one.
when driving a vehicle,
When driving a vehicle. No. No. When driving a vehicle. You have to use when accelerate a vehicle. Driving is not appropriate word. Okay. When accelerating a vehicle.
okay,
In a motorbike, we have accelerator. No? In a four-wheel type vehicle, four-wheel or six-wheel or more than three-wheel type vehicle, we have accelerator pedal, no? Just like we have to push that one by the leg, no? That is called as accelerator. In the later, we discuss how that happen. Until now, uh, until we move to that extent, we just discuss like this. Okay, do you make the corrections?
yes, sir.
Okay, then next on change the direction. No? What is the example? Change the direction.
When walking on road,
In walking on road, how we can you explain that now?
so sometimes the road had bends and all, no, sir. So the direction changes.
So what is the application of force on that?
Change direction.
Change direction. Hmm, yeah, that is also correct. But shall I write another example for that now?
Okay, sir.
Uh, write like this. Change the direction of a ball. Change the direction of a ball. Change the direction of a ball when someone hit on it. When someone hit on it. Uh, I think it is better to write like this. Change in the direction of a moving ball. Can you make that correction? Change in the direction of a moving ball. Finish. Are you still writing?
No, sir, done.
Okay. Then what is the last one?
When applying force to a sponge,
Force to a sponge. Force to a sponge, and you have to write the effect. Okay. Force to a sponge. It change the shape. Then that is 100% complete. It change the shape. Change the shape.
okay, sir.
Okay. Then let's move the next topic. Then we have to learn about types of forces. Types of forces. Types of forces. Then I will categorize force. I will categorize force uh, to two categories. Okay, for two categories. One is contact forces. Contact forces. Other parties, so other categories, non-contact forces. Non-contact forces. Do you know the meaning of contact forces and non-contact forces? Contact and non-contact. So can you give me an example for contact force and non-contact force? Okay, listen. To origin a contact force, okay, to origin a contact force, two or more objects should be contact each other. Two or more objects should be contact with each other. Okay, as an example, friction. Friction. So what is the meaning of friction? Any idea? What is the meaning of friction? Do you know the meaning of friction? Sorry,
And I'm
I
remove
did.
this now.
Okay. Friction. Friction mean think like this is a surface and you kept an object on that surface. Okay. Then you try to drag this one on the surface. So what happened? Due to the friction between this object and this force, a force is generated. Okay? A force is generated opposite to the moving side. If this is moving to this side, friction force is generated to this side. Actually, that is a kind of obstacle, obstacle to move an object. Clear? We have to talk about this friction force and other forces. I want to explain you what is mean by contact force. Okay, this friction force is generated because of contacting this object and this flow or this surface. No, can you understand that part? When this surface and this object is touch with each other, friction force generate. Clear?
Yes, sir,
Those
clear.
are known as the contact forces. Contact forces. Okay. Then non-contact forces. Non-contact forces mean to apply a force, objects are no need to contact physically. No need to contact with each other physically. As an example, think like this. What's called that? This is sun. This is earth. You know that earth is attracted towards the sun. No, earth is attracted towards the sun. Do you know that? No? This is not moving towards the sun because
Yes.
of its motion. Because of its motion. There is two terms for that force: centrifugal force and uh, yes, toward the sun, centrifugal force. In the previous syllabus, we had to talk about that one, that two forces. In the new syllabus, that is not in our syllabus. Okay, this one. Fine. Think like this. When you when you put stone or something from an higher place, what happened? What happened? You move to a top of the building and what's called move to a building and put something towards the ground. Okay, so what happened? Will it freeze on the atmosphere or move towards the ground?
Move towards the ground.
So what is the reason? What is the reason? If we jump from a
Because of
building,
the friction.
no, not because of the friction. If we jump from a building, we fall down. No? What is the reason for that? No? What is the force?
Gravitational force.
Yes, gravitational force. Gravitational force. So this gravitational force is occurred. Okay. This gravitational force is occurred as a non-contact force. As a non-contact force. Think like this. This is a stone. Okay, this is a stone which come towards the ground. There is nothing touch with it, no, but it moves toward the land or ground. It is due to the gravitational force. So non-contact example for non-contact force is gravitational force. Are you clear about contact forces and non-contact forces?
Yes, it's clear.
Okay. Did you write the topic? Types of forces?
Yes, you're wrong.
Okay. Then write forces can be forces can be forces can be mainly categorized under two criteria. Mainly categorized under two criteria. Either number one, contact forces. Contact forces. Second one is non-contact forces. First one is contact forces. Second one is non-contact forces. Non-contact forces. Clear?
Yes, sir.
Okay. Then write the subtopic as contact forces. Contact forces. Contact forces. Contact forces. Write down this one. These require, these require, these require, these require physical touch between, physical touch between objects. Physical touch between objects. These require physical touch between objects. Objects. Okay. Under that one, write, write, uh, write friction, friction, friction. I will give 2, 3 examples. Okay. First one is friction, friction, friction. Finish writing.
Yes, sir.
Okay. Right. When an object is right, when an object is, when an object is, when an object is moving on a rough surface O, when object is moving on a rough surface O, rough surface O, rough surface O, try to move on a rough surface, try to moving on a rough surface, try to moving on a rough surface, try to moving on a rough surface, friction is generated, try to moving on a rough surface, friction is generated. Friction is generated. Finish writing.
Yes, sir.
Remember, remember, always friction is generated from the interface of two surfaces. Okay. Interface of two surfaces. Interface means the middle of two surfaces. Here is the friction. 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 This is the direction. This is how we named. This is how we denote the friction. Okay. Denote the friction. Clear about this or not? Do you have
Yes.
any doubt?
No.
Okay. Then draw this one. Draw. Finish.
Yes, sir.
Okay. Then next one. Next one is tension. 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 Tension.
That
Okay. Do you know the meaning of tension? Or what is the instant when tension is generated? Where the tension can occur?
no idea, sir.
Tension is occurs in strings. 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 Think like this. The object is hanged by a string. This is the object. The object is hanged by a string. Then, then the tension forces are apply on this one. Apply on this one. Clear? If not, think like this. This has weight, no? This has weight. This object has weight. Due to the weight, due to the weight, this string get stretched, no? Stretch. Understood?
Yes, sir.
Okay. Due to that one, tension forces are occurs. Tension forces are occurs. We denote tension forces in this manner by the letter T. By the letter T. Actually, this is actually this stretching is not due to the tension, but to understand the concept, I told you this one. Okay. Later, I will tell you what is what is the different in here. Okay. For now, think due to the weight, tensions are okay. Due to the weight, stretching is happen, and due to this stretching, tensions are okay. Understood?
Yes, sir.
And remember, this is important. This is important. Always tension happen upward. Always tensions are going upwards. Upwards. Okay, then shall we write that down?
Okay, sir.
Uh, right. The force, the force, the force, the force occurs in, the force occurs in strings or ropes. Strings or ropes. Strings or ropes. Strings or ropes. Shall we write some example for that one? Write example. When elevator is held by a cable. When elevator is held by a cable. When elevator is held by a cable. Do you know the meaning of this song? Tug of war. Meaning of this song? No? Tug of war.
It means that
Sorry?
tug of war means in the New Year festivals that people
Yeah.
that one,
Two
right, sir?
parties. Yes. Two parties try to, what's called that?
Pulling
By
the
using a rope. Yeah, pulling, not, yeah, pulling. Yes. Two parties try to pull the rope towards themselves. That is known as the tug of war. No? When they are pulling that one, tension is occur. Tension is occur. Clear? Tension is occur. Tug of war. Then write the next example. When playing tug of war. When playing tug of war.
sir, in that
This,
case, how is the tension? What that is the direction of the tension is like both sides, right,
yes.
sir?
That is correct. That is correct. In this kind of situation, tension is always suffer towards the upward. Okay.
Okay, sir.
In this one, tensions are happening both left and right side. Your question is very good. Okay. Actually, actually I had planned to ask you that question from you. Okay, then can you draw this too?
Sir,
Director,
pitch, yeah. Okay, sir.
is it drawn?
Sorry, sir.
Is it drawn?
No, sir. I was asking to draw these two pictures.
Okay, okay. Draw that one.
That's
Okay. Next one is right. The next one. I think I need anything. Next one is third one, no? Normal force. Normal force. The third force. Third type of force. Normal force. Normal force. Finish writing?
yes, sir.
Okay. Do you know the meaning of normal force?
No, sir.
Okay. Normal force. Normal force is generated due to the weight of an object. Okay. Due to the weight of an object. Due to the weight of an object. Okay. Then it is like this. Uh, this is a book. So book, okay. And this is kept on a table. This is kept on a table. And this book has a weight, no? This book has a weight. Okay. Due to this weight, okay, listen carefully. Due to this weight, what happened? This book apply a force on the force on this surface. Due to this weight, what happened? This book apply a force on the surface. This is the surface or on the table. Surface or table. Due to that one, due to that force, a normal force is generate like this. Clear? Yes or no?
Yes, sir.
Okay. Why does a normal force generate? Due to the weight. Okay, simply due to the weight. What happened there? Due to the weight, the object applies a pressure on the surface. So due to that pressure, okay, due to that pressure, a normal force generates. A normal force generate. I will explain you this when we come to the Newton laws. Okay. Again, when we come to the Newton laws, until that, this is enough. Till that, this is enough. Okay. Then there is a specific characteristic of this normal force. Specific characteristic, that is normal force. Okay, normal force always generate or always origin perpendicular to the surface. This always generate or this always origin perpendicular to the surface. What is mean by perpendicular? What is mean by perpendicular?
Straight to the 90 degrees angle.
Yeah, from 90-degree angle. From 90-degree angle. This always origin to 90-degree angle to the surface. Clear? Then think like
Yes, sir.
this kind of instance. This is an inclined force. Inclined, not force, inclined plane. Inclined plane. And object is placed on the inclined plane. This weight is always towards the land or towards the ground. And remember this also, this mg or weight, both are same. Mg and weight is always perpendicular to the ground. Okay. I will tell you again when we come to this force. Always this is perpendicular to the ground. Weight of mg, okay? Then how we can draw a perpendicular line to the this inclined plane? How we can draw a perpendicular line? This perpendicular line should be like this. Like this. Understood? Now we can mark a 90-degree angle in here. This is our. This is our. Then tell
Sir,
me.
so
Yes.
weight and the weight and the normal force is not in the straight line, right, sir?
It is like this, okay? Actually, I will come to that point. Uh, if it is an inclined plane, okay, if it is an inclined plane, normal force and weight is not equal, not equal, and it is not in same line, not in same line. Clear? You can clearly see that on. Or if I
Yes, sir.
extend the mg, it is going towards this. If I extend the R, it is come to this one. But in here, what happened? R is, or normal force is equal to weight to mg. Normal force is equal to weight to mg, and it is in line. In line. So it is in the same line. Same line. Are you clear?
Yes, sir.
If it is in a horizontal line, R is equal to mg. It is, if it is in a what's called that inclined plane or inclined line, that is not equal to weight of mg. Are you clear?
Yes, sir. Clear.
Okay. Then let's write. We wrote the topic, no? Normal force as the normal force.
Yes.
Okay. Then write down this. When an object is on a surface, when an object is on a surface, when an object is on a surface, the surface is pushed by the surface is pushed by the surface is pushed by the weight of the object, weight of the object, weight of the weight of the object. To the same point, to balance the weight, to balance the weight, to balance the weight, the internal force called an internal force called an internal force called normal force is origin. Normal force is originated. Normal force is originated. Normal force is originated. Finish writing.
Yes, sir.
Okay. Then draw these figures. Draw these figures and draw this figure as separate figure. Okay. This is on an inclined plane. No? This figure as a separate figure. Separate figure mean if you are drawing in a book, don't draw like this. Okay. Don't draw like this. Uh, draw this 1 and 2 in the both side, and after that draw the third one. So this is different. That's the reason. Do it quickly, okay? Still drawing?
Yes, when I draw the third picture.
Okay.
Done, sir.
Okay. This tree is not. Then let's move to the next topic. First we discuss about contact forces, no? Second one is non-contact forces. Second one is non-contact forces. Non-contact forces. Okay, then tell me what is the meaning of non-contact force? Non-contact. Take the meaning from this to non-contact.
Forces that do not contact the surfaces.
Forces which are
That do not contact the surfaces.
okay, which are not contact by surfaces. Or the forces which are not contact physically, no, not contact physically. That forces happen when the objects are existing on some distance. Clear? Okay, then
Yes.
let's write. This forces act. This forces act. This forces act. Like at a distance. These forces act at a distance. At a distance. At a distance. Without having a physical touch. Without having a physical touch. Without having a physical touch. Finish writing.
Yes, sir.
Okay. Then actually I missed to write a sentence in the last topic. I think we didn't write that the normal force is always perpendicular to the surface. Did we write that one?
No, sir.
Can we write that? It is very
Okay.
very important. It is very very important, right? Normal forces are always perpendicular to the surface. Normal forces are always perpendicular to the surface. Sorry about that. I missed to write that.
Done, sir.
Okay, then let's try the first type of contact force, that is gravitational force. That is gravitational force. Gravitational force. Gravitational force. Finish writing.
Yes, sir.
Okay. Gravitational force. Gravitational force means always, always every object is attract towards the ground. No? Always every object is attract towards the ground. Towards the ground. Okay, then can you give me example? which we cannot find gravitational force. A place which do not have gravitational force. Yeah.
So can you repeat the question?
A place which do not have gravitational force. Do you have an answer?
No, sir.
Sorry?
No, sir.
Oh, simple question. In the space, what happened?
Yes, sir. No gravitational
In the
force.
space, no gravitational force in space. No gravity. No gravitational force in this space. Actually, before they go to the space, they get a special training because from the birth we are dealing with the we have dealing with the gravitational force now. So once they move to the space, I'm talking about the astronomers. Okay, once they move into the space, they cannot deal without gravitational force. They should have the special training before move to the space. They take that training. After they come back to the Earth, again they have to face a special training because they have lived uh, several months or several years without having the gravitational force. No? So they cannot perform uh, as were they on the Earth. They take a few weeks to settle that condition again. Clear? Their blood pressure also change, totally change. Total change mean not to a fatal limit, but somewhat they change. Understood?
Yes, sir.
Then the next thing, what is the gravitational acceleration of the Earth? Earth gravitational acceleration. In the Earth's surface, it is around 10 ms minus 2 squared. In the Earth, it is around 10 ms minus 2 squared. In the moon, we usually say it is around 1/10 of this sun. 1/10 of Earth gravitational force. Earth gravitational force. Clear? Then the thing is, when we move from planet to planet, this gravitational force is change. This gravitational force is change. Clear?
Yes, sir. Clear.
Okay. Then let's try it like this. Right? This is the attraction towards the ground. This is the attraction towards the ground. The attraction towards the ground. Attraction towards the ground. And the next point, there is no gravitational force in the space. There is no gravitational force in the space. There is no gravitational force in the space. Next point. Next point. Gravitational force. Gravitational force. Gravitational force changes. Gravitational force changes from planet to planet. From planet to planet. From planet to planet. Okay, finish writing.
Yes, sure.
Okay, then draw this small picture. Draw this small picture. Finish drawing.
Yes.
Please show still one more time.
That's finished drawing.
Okay. Then let's try the next one. Okay, okay, all things are finished. Then move to the next one. That is weight. Second one is weight. Weight.
Sir, I
Yes.
that gravitational force equals to 10 ms.
Sorry, gravitational force.
Should I write the unit also, sir?
Gravitational force. Force mean what is the unit? Force mean that is Newton.
Yes, sir. No, sir. I mean that this one, sir, like 1/6 and all.
You need this one.
Yes, sir.
Okay, okay. I will explain it in under the weight. Okay.
Okay.
Actually, gravitational force and weight are we can consider it as same, but I took this as two topics because I want to teach you something. Okay, because that is most of the people. Uh, Most of the people have understand it in correct manner. That's the reason. Okay. Okay. Then tell me what is the difference between mass and weight? Mass and weight. Mass and weight. This is the main reason I took this as a different topic. Mass and weight. Do you have any idea?
No, sir.
Mass and weight. Give me a second because this is lagging. No? What are the unit of mass and what are the unit of weight? What are the unit of mass and what are the unit of weight?
Mass equals kg.
Mass equal this one. Shut it. Then weight. What is the unit of weight?
Mg.
Mg? No, 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 not mg. Weight of unit is not mg. Mg mean the symbol. Mg mean symbol or the equation. Okay. Mass is measured by kilograms. Kilograms. Remember when we writing kilogram or kilograms, you have to use simple K. Okay. Kilogram. Weight is measured by Newton. Weight is measured by Newton. Okay. Then the thing is this. If you multiply mass by gravitational acceleration, it is equal to the weight. Okay. It is equal to the weight of gravitational pull towards the earth. I can write like this. Weight equal mass into gravitational acceleration. Gravitational acceleration. Acceleration. Gravitational acceleration. Okay. Then by using symbol, I can write mg equal m into g. M into g. Understood why I put mg instead of weight? This is the word. This is how we write it using symbol. Then unit of mg is kilogram. So Newton. Unit of mg is Newton. Unit of unit of mass is kilogram, and unit of gravitational acceleration is ms2 minus squared. This is the symbol. This is written by symbol. These are the unit. These are the unit. This is the word equation. So I can write the equation by symbol. Equation by symbol. This is the equation by word. Clear or not? Up to here.
Yes, sir.
Okay. Then you ask me about this G, the value of G, no? You ask me about the value of G in here. This one. In the earth, it is around 10 ms2 minus square. Around 10 ms2 minus square. Actually, actual value is around 9.84, yeah, 84 something, okay? 9.84 something. But this is not convenient when you're doing our calculation, no? So we take it as 10. As I can remember in the Excel syllabus and it's called that Cambridge syllabus, they are taking it as 9.84. 9.84. And I will give you a tip. This is equal to, okay? This is equal to 5 squared. If you have a calculator, just find the value of 5 squared. It should be equal to 9.8 something. Do you have a calculator with you now?
So answer is 9.86.
9.86. That is quite similar. 9.86. That is quite similar. This can be taken as 5 squared. Okay. Then in the moon, how about that one? It is, however, below 10. Okay. It is below 10. That means if we measure our weight in the earth or moon, earth and moon, okay, earth and moon, our weight is higher in earth, lower in moon. Lower in moon. Understood?
Yes, sir.
What is the reason for that one? Our mass is constant. Mass is constant, but gravitational acceleration is different. Gravitational acceleration is different. Clear? You know, just a figure like this. And I will write mass is equal 50 kilogram. 50 kilogram. Then weight should be equal 500 Newton. 500 Newton. In here, mass is constant, 50 kilogram, but the weight should be around I will put it as 42, 420 Newton. This is not the exact value, okay? Around 420 Newton. For you understand, just for your understanding, okay?
Okay, sir.
Okay. Then write this one. Write this. No need to write this one, okay? Because that is already in here. No? Finish. Why still writing?
Finish.
Okay. Then move the next one. That is hmm, what is the most appropriate one? Let's write about magnetic force. Magnetic force. Magnetic force. Is it the third one? Yes, no? Magnetic force. So what is the meaning of magnetic force? This is a kind of magnet, no? So what should be there to attract these two magnets? What are the poles? Should be here. What are the poles? What poles are attracting with each other?
Magnetic force.
Yeah. Magnetic poles mean it has two poles, no, north and south poles. So what are the poles which attract each other?
North and south.
Yes, opposite poles are attracted, no? North and south. Only the opposite poles are attract. Then same poles, what happen? What is the term we use for that one? Attraction. What is the sorry?
Repel.
Repels. If this is north, this is also north. This repels. If this is south, this should be also south. That means same poles are repels, no? The force which is in a magnet is known as magnetic force. Which is in a magnetic, it's known as magnetic force. Understood? In our syllabus,
Yes.
we have to talk and we have to learn about magnet and magnetic force. That's why I gave it here. Okay, then right. Then right. The force in the magnets are known as force in the magnets are known as magnetic force. Okay, then draw this figure.
That's it.
Finish drawing.
No, sir.
Okay. Then draw.
Done.
Okay. Then as the next one, let's write about what else we have to. We didn't talk about that one, centripetal force and centrifugal force. No? Okay, write the topic. Actually, this is not in our syllabus, but for your knowledge, it is better to write. Centripetal. Wait, I will write that one. Both on, no? Centripetal and centrifugal force. Fugal force. Centripetal and centrifugal force. Finish writing.
Done, sir.
Okay. Centripetal. Centripetal. It is like this thing. This object, and by a string we rotate that part. Okay, by using a string we rotate that part. When we rotate this string, this is moving in a circular path. No? This is moving in a circular path. No? Just like a circular path. This is the center. This is the center. Okay. When this is moving in a circular path, there is a force towards the center. Okay. There's a force toward the center. Force towards the center. Center. Okay. That is known as centripetal force. That is known as centripetal force. Clear?
Yes, sir.
That is known as the centripetal force. Okay. Then there's another force acting towards this side, that is known as the centrifugal force. Centrifugal force. Actually, this is a kind of pseudo force. Pseudo force, so we call it as internal force. Internal force. Internal force. Pseudo force or internal force. This is actually this is known as pseudo force. Because of this reason. When we move this one, when we move this object, we feel it just like try to move towards this side, no? Towards this side, not towards the center. Always it is try to move towards the not towards the center but outward the center. That is due to the mass of this object. Okay, that is due to the mass of this object. Like that's why we called it as a pseudo force, no internal force. Actually, that is not an actual force that happened due to the mass of this object. Clear?
Yes, sir.
Okay. Then just draw this one. This is just for your knowledge. Except this force and the magnetic force, all the other forces we need to talk in this lesson. Okay. Other than that, there are what's called upthrust. Upthrust also kind of force. So that is also a non-contact force. Mm, so I didn't talk about that kind of forces because that is not in this lesson. No? So when we do that lesson, we talked about that. No? But to move further in this lesson, we should have the knowledge of this forces, except this fourth one and the what's called that this magnetic force. Okay, then right, not right, just no. That is enough.